Again, we want to rationalize the denominator, but we can have a binomial in the denominator. So we are going to multiply by the conjugate of the denominator over itself in order to rationalize this denominator. Up in the numerator, we're going to do distribution, and down in the denominator, by design, we only need to do the F and L portions of FOIL. So our numerator is going to be negative 6 times the square root of 7 plus the square root of 5, and the denominator will be root 7 times root 7, which is 7, minus root 5 times root 5, which is 5. Notice I did not distribute my numerator out because I had a little foresight here that the denominator was going to become 2 and that we'd be able to cancel with our numerator. Whoops, that should be root 7 there, plus root 5. Sorry about that. I need parentheses. And now I'm going to cancel the 6 and the 2, have 3 and 1, and we can rewrite this as negative 3 times the square root of 7 plus the square root of 5. Finally, let's solve this radical equation. We already have one radical isolated, so we're good there. We want to square both sides to lift off at least the radical on the left. So the left side is going to become x plus 2, and on the right we've got a FOIL problem. 1 minus the square root of 2x plus 5 times again 1 minus the square root of 2x plus 5. No change on the left, but on the right we have a FOIL problem. The first term is 1. Now the inner and the outer are negative radical times 1, so minus 1 radical, and then outer is another minus 1 radical. So we're going to have minus 2 of these radicals of 2x plus 5. The L term of FOIL is going to be negative times negative, which is positive, and then we'll have the root undo itself to give us 2x plus 5. Now what we need to do is a little bit of simplification. I'm going to subtract off the 1 on each side, subtract off the 2x on each side, and subtract off the 5 on each side. So my left side is going to become negative x minus 4, and the right side will be negative 2 square roots of 2x plus 5. I want to isolate the radical and divide by negative 2, but that's going to create a fraction on the left. So instead I'm just going to divide by negative 1 all the way across just to get rid of those negatives. That leaves me with x plus 4 is equal to 2 square roots of 2x plus 5. Now I've got a radical that I can square, and the left side will again become a FOIL problem. So we will have x plus 4 times x plus 4 equals 4 times the quantity 2x plus 5. We then have distribution on each side. The left side becomes x squared plus 8x plus 16, and the right side is 8x plus 20. So I'm going to subtract 8x on each side. This is quadratic, so I want to set it equal to 0 by subtracting 20 on each side also. And that leaves me with x squared minus 4 equals 0. We recognize that as the difference of two squares, and we know that we're going to end up having x equals 2 or negative 2 as solutions. Now, because we're dealing with radicals and because we've been squaring each side twice, we really do need to check these answers. So let's start with 2. Going up to the top of the problem here, we have 2 plus 2, which is 4, which square roots to 2 inside the radical. On the right, 2 times 2 is 4, plus 5 is 9, which square roots to 3. 1 minus 3 is negative 2, but the left side was equal to positive 2. So we need to go down here and cross off the 2. Let's check the negative 2 solution. When we substitute negative 2 on the left, we get the square root of 0, which is 0. Negative 2 inside the radical gives me negative 4 plus 5, which is 1, which square roots to 1. And we have 1 minus 1, which is 0. And so each side is equal to 0, and negative 2 is a valid solution. It is a very common mistake for students to not check their answers to these type of problems, and you really do need to do so.